So today we are going to see how to create FB function block, and we see how to create DB. Okay. Now, as we have seen FC and FC, how to create FC without parameter and with parameter, right? Two methods. Without parameter, we are giving direct addressing, right? And you can call this block only one time. Whereas in FC, we are using parameters. By using parameters, we are creating a logic. Okay. So you can call that logic many times with different addressing. Okay, that's the advantage. Now, next thing is function block. So function block is also known as subroutine. Okay, so here also we are having two methods. One is without parameter, another one is with parameter. Without parameter means direct addressing you can enter in FB. Okay, so here I create FB here, same like a function we have created in last class. FB1. I give some name like logic 3 something. Say okay. Double click, open this. So here also you can create a logic using direct addressing. For example, I am creating one logic here. Okay, so I give address like I1.0, I1.1, Q1.0, and Q1.0 for latching. Okay, now I save the block. Okay, now go to OB1, open OB1. Just like we have called FC, the same order you can call FB here, the next network. From instruction window, we're having function blocks folder here. You can drag and drop or double click. Now, so when I call this block, here you can see it is asking for address. Okay, so here we have to give a data block address. Okay, so here I give like DB1, enter. 1 second. So now when I click on enter, what it is saying, the instance data block DB does not exist. Do you want to generate it? Say yes. Instance DB means this DB1 is assigned to FB block only. Okay, for that FB block. So it is storing the details or logics of that logic status of the FB block only. Okay, now I save this. Then I go to semantic manager, open DB1 if you want to see what is there in DB1 now. So here it shows you nothing here. Okay, but it is taking memory in DB1. Okay, your FB is taking memory in DB1, but it is not showing anything here because we are given direct addresses in FB1 itself. Okay, in FB1 itself we are given the direct addresses. Now we need to download, select and download these blocks. OB1, FB1 and DB1. Okay, download these 3 blocks. Say yes. All. Yes. Now by checking the result, here you can see the result. Now when I give the input here, the output is on, right? I give the output, stop. So it is stopping. Okay, so this is first method with direct addressing here, but you can call this FB1 in OB1 only one time, but we have to assign one DB. Okay, Now another method, as we have seen yesterday, creating FB with parameters. So again I create one more FB here, function block FB2. Here also I give some name like with parameters, so I give some name, say okay, in FB2. Here also we are having this hidden window, and drop it down. Same way we are having in, out, in, out. Okay, so here also I create start. So when we create start, stop, these addresses will be generated here. Okay, it is generating the DB addresses here. So here we no need to, we are not allowed to change anything here. Okay, so it is auto generated. Okay, now in out, one, oh, sorry, one, for out, I'll take, okay, now here also I make the logic just like we have done in FC. So here start, stop, here motor 2, motor 2 has output taken, motor 1, okay. Now save this FB2. Now open OB1. Here I'll show the example here by calling FB2. Now if I delete these addresses here for FC, you can see the difference here between FC and FB blocks. Right? Here in FC, it is asking for the addresses here. Right? For start stop, it is a mandatory addressing, but here for start stop, it is optional. Okay, but at the top of the block, you can see there's a question mark. It is asking a memory block for storing your logic status or values. Okay, so I delete this one, FC2. Now this is optional, but I give some address here 1.2, and we see the example here how we can use it. Q1.2 and Q1.3. Now here what we address we have to give DB address. So DB2, I give another DB. Okay, not DB1. I give another DB because DB1 is already given to this FB. Okay, enter. So when you click enter here, again the message is coming. Instance data block DB2 does not exist. Do you want to generate it? Say yes. Now I save this. Go back to Semantic Manager. Download OB1, FB2 and DB2. So yes, all, yes, that's it. Now check here. So when you operate this input I1.2, right, the outputs are working. Now to check the result in DB2, say yes. Here you can see it is showing you the parameters which we are declared in interface, right? And the parameter list start, stop, M2, M1. So there it has already generated the addresses which is taken in the DB automatic. Okay. Now here also you can monitor the result. Here you can see spec symbol is there. When you click on the spec symbol, it comes online. Here you can see it is showing actual value and actual value. Initial value will be false for all the inputs or outputs. Okay. Now actual value, here you can make any changes you need. Here this is your present online value . So when I operate any input here, you can see status here true, right? True status. Okay. Now this is how we are executing our FB. So advantage of this FB here and using DB, right? So the same thing is happening in FC as well as in FB. But here, if example, I delete this stop address. Now there is no address for stop. Okay. I save this and download only this block because I made only in because I made change only in OB1, right? So I'm downloading only this same block. Now, so for stop there is no address. So I give the start command because I'm having address for the start. So your DB here, if you see, right? So when I give this start, it is taking the status of that I address, right? Now there is no address for stop, but we are having address for this stop in your DB. Okay, so this address you can access here, like I make it 1, and we are having this download parameter setting data. Click on this, you can see it has changed the status to true and the outputs are off. So again make it to 0 and download it again. Means if you are giving the address, it takes the address status. Otherwise, if you are not using any address here, just like for stop, you can access that stop DB address, which is like an internal memory for your stop. Okay, internal memory of PLC for your stop. Okay, so there's the advantage here. You can change the status. Okay, but one more thing, if you are giving the address, it will take the address status only. Just like when I operate I1.2, that status only it will take. Okay, if I am not giving the address status, then for that parameter you can access in DB. Okay, 1, download this, right? 0, download it. Okay, so this is the example for your function block. Okay, now this is about FB. So our next topic is shared DB. Okay, how to create shared DB. So here also the process is same. Go to the schematic manager, blocks, right click on blocks, insert new object, data block. So what is shared DB here? If like for example we are done, we are used this M address, MW0, MW2, MW4, MD0, right? MD10, 20 like that, right? So here we need one structure for some machine, for some process. Okay, we're having some analog values and digital values also, right? So for storing their status, I need some memory. Okay, so for that I can create one structure here in data block. I can create one structure means for this temperature I need this memory, for this pressure I need this memory. So I no need to keep on calculate how many bytes and byte number we have to use. Okay, so here you can directly create a list. Okay, in data block. So just select this. Now what the number it is showing here, DB3. So it is a shared DB. So when you expand this, it is showing you the instance DB option also. If you select instance DB, it is asking for FB, for which FB you want to use this as a instance DB. Okay, so from here also you can create an instance DB, but you need to create some FBs for that. Now we are going to create shared DB. Select shared DB here and give the symbolic name, like for machine 1 something. Okay, and say okay. So DB3 is generated here. Open it. So this is the view for your shared DB. Okay. So for instance DB, you have seen right already. Instance DB means, sorry, DB2. It is taking the parameters, okay, which we are declared in FB, right? FB interface, right? It is automatically taking this here. But for shared DB, we're having another format. This is the view. Okay, here we have to create our parameters. Okay, just like I create start, bool, start, command for motor 1 from SCADA, stop, bool 0, stop, command for motor 1 from SCADA. So why I'm creating this? Not just from SCADA, from HMI also you can create. Okay, so because we cannot write into the I address of PLC from SCADA. Okay, we cannot write from SCADA to I address of PLC because I address is I address of your PLC is linked to the hardware. Okay, switch or a push button. So SCADA is a graphics, right, which is in your PC or HMI, right, on a screen. So when you press the button on the screen, will this switch get activated automatically here? No, not possible, right? So until that switch is on, that input status will not be updated. So that's why we cannot write directly into the I address from SCADA. So we are using internal memory to bypass that I address to control from SCADA to operate any input command from SCADA. But we can write into output address of PLC from SCADA. We can read and write output status. Okay. So I'm not creating any motor memory here. Okay. For your SCADA. Now another example, like if you want to store some values for some parameter like pressure 1, I take the data type as real. Okay. So it is taking some address here 2.0. Okay. So this is the address for the pressure. Now when I create pressure 2 real, next one pressure 3 as real. Okay. Any other data type like temperature, like you temp 1 as like integer, temp 2, temp 3. Okay. So like this you can create one structure here. Okay, temperature, pressure, flow, speed. So it is generating some addresses automatically here. Okay, so here for start your address will be as in the last class we are discussing about the DB addressing format. So first we have to mention the DB number. So what's the DB number is DB3. DB3 dot DB X 0.0 byte number dot bit number. Right, so db3 dot dbx 0.1 for stop. Now pressure is a real format, so it is a double word address. That means db3 dot dbd2. Okay, similarly for 2. Okay, pressure 2, 3 also 6 and 10. So here we are not using dot 0.1 for any real integer or double integer data types. Okay, only for boolean we are using dot 0.1. Okay, so this is a format we are creating one structure here in the DB. Now how to call this address in your program? So I need to close this window, complete window I'm closing, even I'm closing OB1. So restart your OB1 so that new DB what we have created, okay, that effect should take in your OB1. Okay. Now I take a new network here. So here our logic will be like this. For your PLC and SCADA both operation. Okay, so here I give the address like I 1.5, then I 1.6. One second. Then for output say I 1.4 something. Sorry, Q 1.4, Q 1.4 for latching. Now here I am making this parallel input, one more input here for SCADA command. Okay, for start. Whereas this one NC for stop. Okay, so how to call this address? Select here, press D. This showing you the list of your DBs. Okay, so machine 1 underscore logic. Okay, that is your DB3. Right, so expand this. So don't select this start stop. Okay, this is for the symbol table. You have to select from our DB. Okay, it is showing you the DB3. In this, you can see start. Select this address. Now you can see DB address is automatically selected here. Next, D again stop like this. Okay, automatically it will take the address. Similarly, for calling your another data types, what we have created real and integer, right? So for example, I take integer function add integer. Okay, add function I'm taking here D machine logic temperature 1 with you can see the address also it is showing temperature 2 db3 dot dbw 14 16 like that. Okay, so whenever we create this shared db, always give a symbolic name. Okay, in properties, if you do not give the symbolic name like I have given machine 1 underscore logic, okay, it will not display this address. Okay, so always give the name. Now for real, it is showing you only the real data types. Okay, for integer it will show you only the integer data types like this. Okay, now I save this block, then go to schematic manager, select OB1 and DB3, download these two blocks. So yes, all. Let's see, let's check the result here. Okay, so as your DB is an internal memory, that means you can access it directly from here also, or you are getting this status from your SCADA. Okay, modify to 1, right click, modify to 0, your output is on. From here also you can modify to 1, modify to 0. So this status we are getting from SCADA. Okay, next below add instruction, modify some value like 45 plus 0 45, right? So modify something 60. Okay, for real value right click, modify. All these values we will be reading directly from field. Something. Okay, if you want to see these values in your shared DB here, that also you can do. You can open it. Here also we are having monitor on off option. So from here you can see the result. We are adding these two memories and storing here. Adding these two memories, this is the result. If you want to change a value here, that also you can do, like 150.67 something. Here 230.6. Okay, then we're having this download option. Download from here. Say yes. The values are updated. Okay. Similarly for this temp. Okay, these values you can change. Okay. So this is how we can operate from here also from DB through this shared DB option. So this is one structure. Structure means you can see one boolean, one real, one integer. Okay, different data types we are creating. Okay, some model. Okay, it's like a structure. Okay, for one machine. Okay, so these are what the shared DB, and we are seeing how to call these addresses.